Okay, so let's move on to special project of a binomial and a trinomial. So this is the binomial, this is the trinomial since it's two numbers, and this is three numbers. Okay, so first I'm going to start off by explaining how this multiplies out into x cubed plus y cubed. Okay, so we know by now that it will be x times this entire bracket plus y times this entire bracket. So let's go ahead and do that. So x squared minus x y plus y squared, and then in a second. Okay, so let's multiply out these brackets. So x times x squared, that's x cubed, and then x times minus xy, that's minus x squared y, and then x times y squared, that's plus x y squared. Okay, so moving on to the second bracket, we have y times x squared, so that's just plus x squared y, and we have y times negative xy, which becomes negative xy squared, because y times negative xy is just y times y squared, and yeah, and then we have y times y squared, which of course is y cubed. Okay. And so looking through the terms that we have, we can actually see that we have a negative x squared y and a positive x squared y, and that we also have a positive xy squared and a negative xy squared. So these values going to cancel each other out. So minus x squared y plus x squared y will become 0, plus xy squared minus xy squared equals 0. So that only leaves us with x cubed plus y cubed. So I think this should be cubed. So there you go. X cubed plus y cubed, which is exactly what we see right over here. And so then let's multiply this equation and show how it is equal to x cubed minus y cubed. X squared plus y squared minus y, x squared plus plus y squared. Okay? So multiplying it all out again, we get x cubed plus x squared y plus x y squared minus x squared y plus x, sorry, that's negative, because it's negative y times xy, so that becomes negative xy squared. Sorry for that. And then negative y times y squared, negative times positive, so it becomes negative, so it becomes negative y cubed. Okay? And once again, we have terms that cancel each other out. This positive xy squared is canceled out by this negative xy squared, so we cancel those out. This x squared y is canceled out by this negative x squared y, because they cancel each other out. That's resulting in x cubed minus y cubed, okay? Which is the same as what is given to us by the special product. So let's give an example. Let's just say in our example, we get 7 minus b, and I am writing out an example for the second equation, since this one is a bit easier to get with the positive x2 plus 5. Okay, so 7 minus b, so then is because we've established that our 7 is x, so x squared will be 49, 7 times 7 is 49, plus xy, so 7 times 7 times b, 7b, plus b squared. And so we would know now that our answer will be equal to 7 cubed, which is equal to 343, because that's 7 times 7 times 7, minus b cubed. Okay? And so let's expand these brackets to verify that our special product is correct. Okay, so 7, 7 is okay. So let's multiply out these brackets. 7 times 49 is 343. 7 plus 7 times 7b, that's 49b. 7 times 7 times b squared, it's just 7b squared. So now we have negative b times 49, that's minus 49b. And then we have negative b times 7b, so that would be equal to negative 7b squared. And then negative b times b squared, that's negative b cubed. Once again, we have terms we can cancel out. We have positive 7b squared and we have negative 7b squared, so let's cancel each other out. Plus 49b and then minus 49b, let's cancel each other out, which leads to our answer of 343 minus b squared. Same answer that we got by following the special product, the product of a binomial and a trinomial. So yeah, I hope you understood more about special products of polynomials with these explanations.